Okay, let's look at some tougher examples here. Okay, if we use 3.4 moles of O2, and we've got this reaction equation up here, 1 C2H6O plus 3 O2s should be able to make 2 CO2s and 3 H2Os. Don't forget, we can step these up to numbers of moles. So you'd say 1 mole of C2H6O and 3 moles of O2 can react to form 2 moles of CO2 and 3 moles of H2O. So if we use 3.4 moles of O2, how many moles of C2H6O are used in the reaction with it? Okay, well, we want to do a conversion from moles to moles of something else. So I'm going to refer to a little stoichiometry island diagram here. Let's see. So we are going from moles of O2 and try to convert to moles of C2H6O, and that's a 2. It's kind of a sloppy 2. Okay, so our island diagram should show us how we can go from one to the other. It's kind of our sort of safety net for making the right conversion. So to go from moles of O2 to moles of C2H6O, we are using the coefficients from the balanced chemical reaction equation to go from substance A, which is O2, to substance B, which is C2H6O. Okay, so I need to use the coefficients from the balanced equation. So let's set this up. So let's start with what I'm given, which is 3.4 moles of O2. Whatever I'm given has to go out front because that's what I want to convert. 3.4 moles of O2. Okay, now I'm going to convert it by multiplying by fraction bar. Okay, I want to get rid of moles, specifically moles of O2. So that's going to go on the bottom here. Moles of O2. Okay, I'm trying to get to moles of C2H6O. And according to the stoichiometry diagram, that's something I can do. I can go from moles of one thing to moles of the other. I just have to make sure that I'm using these coefficients out front on the balanced equation. So moles C2H6O. Okay, so this conversion factor, this fraction bar here, okay, is my mole to mole ratio. Mole to mole ratio. Okay, and in order to figure out that ratio, I'm using the balanced equation up here. That's telling me how much of this and how much of that can react together to make how much of this and how much of that. Okay, so in this case, it takes 3 moles of O2, there, 3 moles of O2, and 1 mole of C2H6O to react together. Okay, so my ratio is 3 moles of O2 to 1 mole of C2H6O. How do I know that the O2 is going on the bottom? Because my old unit has to cancel out. To do that, to divide it off, it has to be on the bottom of this fraction bar. So I should be left with moles of C2H6O. All I have to do now is plug this into my calculator. Okay, so bring this up. So 3.4 times 1 divided by 3 gets me about 1.13 repeating. So I'm just going to say 13 and round it there. Moles of C2H6O. C2H6O. All right, and that's my answer. Okay, so if I had exactly 1 mole of C2H6O and exactly 3 moles of O2, they could react together to make 2 moles of CO2 and 3 moles of H2O. But if I don't, if I have, say, 3.4 moles of O2 instead of 3 moles of O2, I can still figure out exactly how many moles of C2H6O it would take. If I was doing this in the lab, if I had a number of moles of C2H6O was going to take, I could change that into grams. Same thing with the O2. And that's something I can actually measure out rather than moles. Okay, so there is a reason for this. This is a purpose. Okay, let's try another example. How many moles of CO2 can we produce? Okay, well, I could start back with my 3.4 moles of O2 and go to moles of CO2 this time. So instead of going from my moles of O2 to moles of C2H6O, I could go, let's do this kind of dark blue, from moles of O2 to moles of CO2. Okay. Now I could also go from the moles of C2H6O to moles of CO2, and I should still get the same answer as long as I'm careful about my mole-to-mole ratio. Okay, from O2 to CO2, I have a mole-to-mole ratio of 3 to 2. From C2H6O to CO2, I have a ratio of 1 to 2. So I just have to be careful about what I put in my fraction bar. Okay, but it should come out the same. So it doesn't really matter which one I use. I'm going to stick with my 3.4 moles because that was something that was given to me. That way, there's no chance that this is kind of made for a mistake. Like, there's a chance that I did some math wrong here to get this answer. And if I go and use this answer, that might lead me to another wrong answer because what I started with was wrong. So instead, I'm going to start with this 3.4 moles of O2 again and go from there. But either should work the same. Okay? I want to make it clear. Either should get you the right answer. As long as you do the right conversion factor setup and the right mole-to-mole ratio. So let's start back with our 3.4 moles. Moles of O2. Okay. And again, my stoichiometry diagram says I can go from moles of one thing to moles of another, as long as I'm careful about the coefficients and the balanced reaction equation. This time, instead of it being C2H6O, I'm going from moles of O2 to moles of, was it CO2? Yes, CO2. That way. Okay, so drop my fraction bar there. I have to get rid of moles of O2 on the bottom. So that way I'll divide out and cancel my moles of O2 units. On top, I'm going to have moles of CO2. That's what I'm trying to get to. Moles of CO2. Okay. So this fraction bar, I'm going to quit doing the dotted lines for now because they take too long, is asking me for what mole-to-mole ratio do I have between moles of O2 and moles of CO2. Okay, well, my reaction equation is telling me that for 3 moles of O2, I should be able to make 2 moles of CO2 in this reaction. So 3 moles of O2 can make 2 moles of CO2. And there's my conversion factor. There's my mole-to-mole ratio. And again, this is the only time we can't just be 1 with moles and put 1 on the top and the bottom. Okay, so to get my answer, my moles of O2 should cancel out. I should be left with moles of CO2. I plug this in, 3.4 times 2 divided by 3, and I get 2.26666 and a whole bunch of sixes. So 2. Let's say 6. Oh wait, sorry, 26. 2.2. I want to still have the eraser. There we go. 2.267 moles of CO2 that we can make from this reaction. Okay, now a couple things. If you kind of imagine us going from moles of C2H6O to moles of CO2, well, this 1 to 2 ratio between C2H6O and CO2 means we'd basically be making twice as many moles of CO2 as we would C2H6O. And hey, this looks like we doubled it. Okay, just to kind of go to show that our answer does not matter whether we started at moles of O2 or moles of the C2H6O. These are all related and they're all connected to each other. Okay, the only reason I chose 3.4 moles here is because it was safer, because there's a chance that I mess something up here. Okay, but either way works. We can go and convert between moles of O2 to moles of CO2. We can go from moles of C2H6O to CO2. We can go from CO2 back to C2H6O. Okay, so the other point I wanted to make is we can go from a reactant and convert to figure out how much product we're going to make, which is pretty common. We want to know, hey, if I start with this much C2H6O, how much CO2 can I make out of this reaction? We can also backtrack it and say, hey, I want to make this much H2O from this reaction. How much C2H6O am I going to need to start with? Okay, and you can also go back and forth between. If I have this much C2H6O, how much O2 is going to be needed to react with it? Okay, or if I make this much H2O, how much CO2 is also going to be made from there? These are all related in the reaction equation. Since all of this stuff has to be here for this reaction to happen in these mole amounts and these ratios, this can help me figure out anything. I can go from any chemical and any chemical, from a reactant to a product to a reactant to a reactant, a product to a product. I can go any which way as long as I am careful about my mole to mole ratio. Okay, this is the math magic of stoichiometry. Okay, and again, the math has really not changed. It's still just unit conversion. Okay, how many grams of H2O can we produce? Well, again, I could start from moles of C2H6O or moles of CO2 and try and go from there. But just to be safe, I'm going to go back to moles of O2 because that's a number I'm given. Okay, so I want to start with moles of 3.4 moles of, oops, that's pretty bad. I want to erase it. There we go. Moles of O2. All right. I want to convert that. Now, getting to grams, I don't think there's anything where I can go from moles of one thing to grams of another thing. That's a little bit of a jump. So I should go back to my stoichiometry diagram. Okay, so I'm still starting with moles of moles of O2. There. Okay, this time my goal is to get to grams. That's mass. Okay, I want to get to grams of mass, a mass value, specifically of H2O. So I am starting with moles of O2, and I'm trying to get to grams of H2O. So the stoichiometry diagram will help me figure out where my path leads me, okay? In other words, what conversions I need to make. In order to get from moles to grams, I can't just be like, I'm going to jump straight there. I wish, but we don't have a conversion that goes straight from moles of one thing to grams of another. Instead, this is the path I have to take. I'm going to have to go from moles of O2 to moles of the new chemical I'm looking for, in this case, H2O. Okay, that's one conversion factor. And then I'm going to have to go from moles of H2O to grams of H2O. Okay, which is a kind of conversion we've done a lot before. Going between grams and moles is something we've had some practice with. Okay, but this is the path we're going to have to take: moles of H2O to moles of O2 to moles to H2O, and then moles of H2O to grams of H2O. Okay, so since we're hopping 2 spots on the diagram, that means we're going to have 2 fraction bars. One of them is going to be going. Actually, let's do a different color for moles of H2O. Let's do green. Oh, this is going to look very like holiday. Okay, there we go. That's kind of ugly. Okay, so we're going from moles of O2. We're going to have to get rid of moles of O2 on the bottom. Okay, to get to moles of H2O on the top. Moles H2O on the top. Okay, that's our first fraction bar. The second fraction bar then is going to be going from moles of H2O. We're getting rid of moles of H2O now. And we're trying to get to grams of H2O. Okay, so we've plotted our course to get from our moles of O2 to grams of H2O. We have to go from moles of O2, do a conversion factor, to change from moles of O2 to moles of H2O. And then we can go from moles of H2O to grams of H2O with another conversion factor. So this is going to be a two-step problem. Okay, so let's try it. So I'm going to take 3.4 moles of O2 times my fraction bar. Okay, I need to get rid of moles of O2 on the bottom. So moles of O2 is going down there. And my stoichiometry diagram can kind of help me to figure out that to go to where I want to go, I'm going to need moles of H2O next. Moles of my new stuff. My other substance, my substance B. Okay, in this case, my substance B is H2O. All right, so this fraction bar, this conversion factor is asking me, hey, what's your mole to mole ratio between O2 and H2O? So I go and look at the balanced reaction equation, the only time I can't be one with moles. Okay, and let's see. For 3 moles of O2, I should be able to make 3 moles of H2O. All right, 3 moles of O2 can help me make 3 moles of H2O. Okay, so this is a mole-to-mole ratio of 3 moles of O2 to 3 moles of H2O. Nice. So this fraction bar will help me get rid of my moles of O2. It'll get me to moles of H2O, but I'm not done yet. Okay, this isn't quite where I want to be. I want to be at grams of H2O. So in order to get to grams of H2O, I need one more fraction bar, where I am now getting rid of moles of H2O. Put that on bottom. Moles of H2O. All right, what I'm trying to get to is grams of H2O. Grams H2O. Ugh. My pen just keeps dragging. Grams of H2O. Okay, there we go. So this conversion factor is dealing with my molar mass. Okay, and if you were not sure, the stoichiometry diagram is also there to help you on that too. So if you hop back to here, okay, hey, 1 mole is the same as the molar mass in grams of something. So if I am 1 with moles, all I have to do is add up the molar mass of everything in the chemical formula. So I'm going to be 1 with moles. So I put a 1 there for my H2O. And then what is the molar mass of H2O? How many grams of H2O are in 1 mole of H2O? Well, I just add up the numbers from the periodic table. Okay, I happen to have a periodic table up here. Hey. So let's see. I've got each hydrogen is 1.01 grams per mole. Oxygen is 16.00 grams per mole. So I'm adding up 2 H's and 1 O. So 2 H's would be 1.01 and 1.01. That's 2.02. And then my oxygen is 16. So this should come out to be 18.02, squeeze that in there, grams of H2O for 1 mole of H2O. I just added up 2 H's and 1 O. Okay. This next fraction bar will help me cancel out my moles of H2O. And what will be left is grams of H2O, which is what I want, which means my problem's done. All I have to do is plug this all in. So I take 3.4 times 3 divided by 3 times 18.02, and what I come up with is 61 point, 6L, 60, come on, oh, still on the eraser, 61.268 grams of H2O, and that's my answer. So if I start with 3.4 moles of O2 in my reaction, I should be able to make 61.268 grams of H2O. All right, and that's my answer. Okay. Now that we've got some more practice with kind of hopping around on the stoichiometry island diagram, let's do some harder examples still using this reaction equation. If we produce 324.55 grams of H2O, I want to know how many grams of C2H6O we used up and how many molecules of O2 we used up. Okay. Now, should I be scared about the wording of this, the producing and used up? No, we're still just using stoichiometry to go from one chemical to another. This is just kind of in the context of the reaction. H2O is a product. It's on the right side. So it's something that we're making. Okay, C2H6O and O2 were our reactants. So we are using them up to change them into the products like H2O and also CO2. Okay, but these are all related through the reaction equation, which means we can convert between them using a mole-to-mole ratio. Okay, so let's do it. If we produce 324.55 grams of H2O, how many grams of C2H6O did we use up? So we are going from grams of H2O to grams of C2H6O. Let's chart it out. Let's erase all the stuff we've got on here. Clear all this out. Okay, grams of H2O to grams of C2H6O. So we're going to go from mass in grams H2O. Okay, now our goal is to get to grams of C2H6O, grams of something else. I'm going to do blue over here. I haven't done blue in a while. Grams of C2H6O. All right, all right. Now, in order to get from here to here, I wish I could just go straight over there, but I don't have a conversion factor for that. So instead, we're going to have to find a path to go from grams of H2O. We're going to have to go to moles of H2O next. Moles of H2O next. Okay. And then from moles of H2O, we're going to moles of C2H6O. There. C2H6O, moles of C2H6O, and then finally to grams of C2H6O. So we're going to need one conversion, two conversions, three conversions. We're going to need three conversion factors here, okay, to change from grams of H2O to grams of C2H6O. So there's going to be three fraction pairs. One of them is going from grams of H2O to moles of H2O. One of them is going from moles of H2O to moles of C2H6O. And the last one's going from moles of C2H6O to grams of C2H6O. And then I should get my answer. Okay, and my stoichiometry diagram has some hints along the way. Okay, I'm going to be one with moles. Okay, when I'm changing between grams and moles, I'm using the periodic table to figure out the molar mass. Okay, and to go from moles of one thing to moles of another, I'm using the coefficients from the reaction equation. It's the only time I can't be one with moles. So, with our course charted out, let's try it. We produce So let's start with that. So we have 324.55. That's not a 6, it's a 5. Grams of H2O. Oop. Times. All right, on this first fraction bar, we're getting rid of grams of H2O, so that's going on the bottom. Grams of H2O. All right, we're getting 2 moles of H2O2 then on top. That's the next bubble we're going to. Grams of H2O to moles of H2O. So moles of H2O is what we want. There we go. Moles of H2O is what we want on top. Okay, so this conversion factor is asking how many grams of H2O are in the one with moles. 1 mole of H2O. Well, we add up the molar mass of 2 H's and 1 O. Each hydrogen is 1.01. Each oxygen is 16, just like what we did up here. So it should be a molar mass of 18 point. Ugh, my pen is dragging so much. 18.02 grams of H2O. Okay, that should be my first fraction bar. This helps me get rid of grams of H2O. My second fraction bar should now help me get rid of the moles of H2O that I don't really want, but I just need to have on the path to get there. Okay, well, what's coming next? My stoichiometry island diagram says I have to go from moles of H2O to moles of C2H6O. So my old stuff on bottom is my moles of H2O. Moles of H2O. My new stuff is going to be moles of C2H6O. Moles C2H6O. Okay. Well, I would love to just be one with moles on both of these, but I can't. This mole to molar ratio means I've got to go look at the balanced reaction equation and see what my relationship is between H2O and C2H6O. Right? Let's do purple this time. So I'm going from 3 moles of H2O to 1 mole of C2H6O in this case. So it's a 3-to-1 ratio. So 3 moles of H2O are related to 1 mole of C2H6O. Nice. Okay. So that's another fraction bar down. My moles of H2O should cancel out as it gets divided in this next step, which means we just have 1 fraction bar left, where we are going from moles of C2H6O to particles. Or sorry, grams of C2H6O. Oh man, I'm thinking at the next one. So we're going to grams of C2H6O next. So the unit I'm trying to get rid of, let me keep with my color coding, getting ahead of myself. I'm trying to get rid of moles of C2H6O. I want to get grams of C2H6O. Grams of C2. Oof, that wasn't even close to it, too. C2H6O. Okay, so this is a molar mass ratio, kind of like what I had right here, except flip the other way. So in 1 mole of C2H6O, how many grams of C2H6O do I have? So I go to the periodic table, and I'm going to be adding up 2 C's and 6 H's and 1 O. All right, so carbon is 12.01, hydrogen is 1.01, oxygen is 16. All right, so I'm just going to do it up here. So I have 1 carbon, 12.01. That was a point. There we go. Plus, I've got 6 hydrogens. 6 times 1.01 1.01 plus, oh, I'm sorry, I have 2 carbons. What am I doing? I'm losing it. There we go. I have 2 carbons, C2H6O. So 2 carbons, 2 times this 12.01. 6 hydrogens, 6 times 1.01. And 1 oxygen, so 1 times 16.00. All right, I add all that up. So my 12.01 times 2 comes out to be 24.02. My 6 times 1.01. Sorry, I'm getting trying to type and talk at the same time. I'm just going to add it all up. So that plus 16. It should come out to be a molar mass of 46.08. 46.008 grams of C2H6O in 1 mole of C2H6O. And again, that's just adding up the 2 C's, the 6 H's, and the 1 O. Even though I might have said it wrong like 3 times. Okay, this last fraction bar cancels out our moles of C2H6O. So we take 324.55 times 1 divided by 18.02 times 1 divided by 3 times 46.08 divided by 1. And I get about 276.64-ish grams of C2H6O. And that's my answer. Okay, I'm going to leave this very last one to you guys. I have faith in you. I know you can do it. Okay, use your stoichiometry diagram to figure out your path. Okay, it's going to be very similar to how we started this one. Okay, I would start with your 324.55 grams of H2O. 124.55 grams of H2O. All right. We're going to need to go from grams of H2O to moles of H2O. But instead of going to C2H6O, we're going to particles of O2. So we erase some of this stuff. We'll be going to moles of O2 and then particles of O2. Okay, so as a reminder, for your last fraction bar, 1 mole of whatever, atoms of something, molecules of whatever, is going to be 6.02 times 10 to the 23rd particles of that stuff. So your last fraction bar should be getting rid of moles of O2 on the bottom so that our answer can come out in particles or molecules of O2. All right, and if we are 1 with moles, in 1 mole of O2, there's 6.02 times, we'll run out of space here, 10 to the 23rd particles of O2. Okay, so that's kind of a hint on your last fraction bar. Okay, good luck with the last one. Hopefully some of this has made sense. Again, use your stoichiometry diagram. Don't forget about your periodic table when you have grams per mole, okay, when you're going between mass and moles. Okay, watch your steps. Always get rid of your old units on the bottom. New units on top. Be careful about what you put in your calculator.